All right, let's revisit our average application from the other day where we want to be able to analyze, validate the user input. So let's see how this original second script works, where we can take any number of numbers. So if I just follow directions, enter some numbers, and then quit, 1, 2, 3, the average should be 2 after I type quit. That works great. However, if I type something other than a number or quit, I have a problem. So suppose I try 1, 2, 3, and then stop. Problem now is it takes the word stop, it's not quit, so it tries to add it to sum. Now sum was 6, but if I try to add a string to a number, Scratch treats the string like 0, so nothing happened to sum. However, count did get updated because I ran through that loop again, and so now I have the wrong count for the 3 numbers I entered. So if I type quit now instead of stop, I get the wrong sum. It should have been 2. Because the count got updated. So we have to try and figure out how to prevent users from entering something that's not a number and counting it as a number. Easy idea we came up with the other day was to say, let's just make sure the number is greater than 0. If that's the case, then we'll be able to not count things like words. But we might want to average negative numbers. So we decided to try and extend it. So I just want to review the logic that we attempted to implement the other day and show the right way to do it. All right, so first we know that if you try to add a string to a number, Scratch turns that string into 0 and then performs the arithmetic. As far as our script goes, checking the input, numbers are okay, quit is okay, but we don't want anything else. Now we know a string is converted to a number for arithmetic, but not for comparison like greater than, less than, or equal to. So if you enter a string as stop, and then you try to compare that to 0, you're going to get true because stop is not 0. Sorry about that. Now, however, if we take stop and multiply by 1, then it gets converted to a 0. So it only gets converted upon arithmetic. And then here we would get 0 is greater than 0, which is false. So this is the idea I was trying to use to differentiate between a number and a string. Numbers, again, are things like 1, 2, 3, 100, -5, 3.14, and so on. The logic we're looking at here is if we have a variable that happens to evaluate as greater than 0, and that variable times 1 is 0, that means the variable has to be a string, because this can't happen with a number. Double check here. If var is 3, 3 is greater than 0, but 3 times 1 is 3, not 0. If we evaluate this logic for the word Gary, we're going to get Gary is greater than 0, but if we multiply Gary by 1, we will get 0, verifying that Gary is a string. So this is the logic right here that determines if something is a string or a number. If this evaluates as true, we have a string. If this evaluates as false, we'll have a number because of the and in between. So as far as our script goes, we do want to accept strings like quit. That's good. We want to stop and then present the average. However, for any other string, if it happens to evaluate as true, this and statement here, then we want to just say, whoa, this is a string, that's invalid input, you need to try again. One way to implement that is with nested if then else statements. So that's what I have a flow chart of here. We looked at this before. So first I just want to say, is what I was given quit? If it is, we want to stop this check and then continue on with the average program. If it's not quit, then we're going to jump and say, okay, is it a string that's not quit? Because we already checked for quit. So now we're in that if then else part here. If it evaluates as a string, we want to say invalid input, try again. And we just want to keep looping through this right here. So we're going to have a loop to go with this. Otherwise, if it evaluates as false, we want to jump out of this check and then continue trying to collect numbers and make the average. So let's make that happen. So there's the cat that doesn't have any checking. Now for the bat. So here is that nested if then else statement. So I have a new procedure defined called another check input. I'll show you the other one later. And it says if the answer is quit, then we're going to jump out of and check another input, and we're going to continue with jumping to state the average because they entered quit. If it's not quit, it's going to jump down here and say, okay, does it make this and statement true? And this and statement, remember, that's how we check to see if it's a string or not. If this and statement evaluates as true, then that means they give us a string that's not quit, and we're going to say invalid input, do it again. Notice this is in a forever loop. So it will jump out into the back end of the forever loop and try again. Is it quit? Is it a string that's not quit? If it's not quit and it's not a string, then it's just going to stop this another check input, and it's going to go back to our repeat block here and look for numbers or quit here too. So that should give the desired result. So let's check it out. Now notice I have another function called check input. At the moment, check input is not being used, so that's not going to affect anything. We'll look at that one again later. Let's run this and see what's going on. Let's see, do we turn off the cat? Turn off the cat. Turn on the bat. Oh, we got to stop the cat from speaking. There we go. All right, let's see what the bat does. All right, same start as before. We're going to enter a number or quit. So I'm going to try 1, 2, 3, and then quit. And it should behave like before. Perfect. Now we're going to try entering stop instead of quit, and it should ignore stop and say invalid input as far as the sum is concerned. So 1, 2, 3, stop, or any other word you want to type that's not quit. And it didn't update sum or count. It said, hey, invalid input, enter number or quit. Oh, right, I was supposed to type quit. And then it exits and gives us the average. Or we could enter more numbers if we wanted to. Okay, it looks like it's working all right. All right, let's look at the other bit of logic. So anytime you want to loop through something and you have to check a condition, you have two options for that in Scratch. You could do a forever with an if, and that if could be an if then else. It could be a nested if then else. It could be a single if. Or you could do a repeat until. So here's the repeat until version. Now the repeat until version looks shorter, but we have to take all of that logic here and kind of compact it, which makes it a little harder to comprehend sometimes. All right, so now this one right here is going to repeat until this thing is true, which is kind of the reverse of what's going on here. If this is true, we do this. If this is true, we do this. If they're false, then we do something else, right? This keeps running the loop here while this statement is false. So the way this one had to work here is we had to say, if this string thing evaluates as false, as true, then we want to jump into the loop. Or if we get quit, we want to jump out of the loop here. So we have repeat until the answer is quit. So once they type quit, we're not going to say invalid. We're going to repeat until it's not a string. That's what this and does. It looks for a string. So we're going to repeat until we get quit or not a string. Otherwise, what we're getting must be a string, and that's not quit. We're going to have to say invalid input. Okay. So again, the repeat until is great, but if your logic is complicated, you might be better off doing a nested if then else to keep track of what's going on. If that goes well, you can try and compact that into repeat until, where you have to get all of that logic into one statement here, which is a wee bit more complicated. All right, I hope that helped. Validating input is always a challenging endeavor. Good luck and do good programming. I'll see you in the near future.